So I thought I would do a quantitative projectile motion problem for you since we haven't got to them in class, and this will give you maybe a little bit of a head start into thinking about the Webassign. Also, I'm not a big fan of the way the read it version of the final question presents it, and I hopefully can do it in a little bit more of a conceptual way that makes more sense to the way we like to think about it in class. But um, this is the daredevil jumping over the school bus problem, and we're given some information. We're told that the width of one school bus, which we can just use at the end to find how many school buses. But the basic information we have is the launch speed and velocity of the daredevil. So we're told that daredevil leaves with a speed of 35 meters per second, in my version at 17.8 degrees. We also are told that the daredevil, he's leaving and landing at the same point, which is kind of important, but it also makes the problem a little easier that we don't have to worry about a landing and launching from different points. So we're basically looking for what we call the range of this daredevil, and we call that the dx, and then we can use that dx to relate it back to number of buses at the end. So step number one in any projectile problem is we can do nothing with that 35 meter per second speed because the vertical motion of this motorcycle and the horizontal motion are both independent of one another, and we have to treat them separately. So the first thing I'm always going to want to do is take that vector. I'm just going to come over here. So there's that 35 meters per second, and we want to resolve that vector into the Vx, right? That would be V initial x and V initial y. And then we're told that that is 17.8 degrees. Okay, so we're going to resolve that vector first, do a little bit of trig. So that means V initial in the x direction would be 35 cosine of 17.8, and V initial in the y direction is going to be 35 sine of 17.8. So all we're doing is breaking the 35 into two independent perpendicular x and y components. So what that means then is that this daredevil is traveling horizontally with a speed of about 33.3 meters per second, and then his vertical launch speed is about 10.7 meters per second. Okay, so that's a very important first step, is that we acknowledge the fact that we can't do anything with an 18-degree launch angle. Everything has to be done with the x velocity and the y velocity, because now we can kind of think about what we talked about in class. The time it takes for this motorcycle to go up and down with an original or initial upward velocity of 10.7 meters per second, he is constantly traveling in the forward direction at 33.3 meters per second. So I have two one-dimensional motion problems in one here. So now let's figure out what we can do next with this. If we're going to start with the Vy, so we don't use the Vx for very much. Vx is ultimately going to be what determines dx, but I know that dx, let's just get it over here so we know what we're shooting for here. Dx is going to be equal to V initial x times t, and then remember, if we think about the whole equation, plus 1/2 ax, right? We never have a y and an x in the same equation. That just wouldn't make any sense. I'm solving for everything horizontal here, but as you probably remember from class, there is no acceleration in the x direction, so that term doesn't really exist. You don't really have to even write it down. I just want you to realize it's the same equation, just without the acceleration. So I know, let's check off what we know here. I know that we're trying to find dx, and I know that he's traveling now. We know that he's moving at 33.3 meters per second in the x direction. But we don't know t, but what we do know is that t is totally dependent upon how long he's in the air, which is totally 100% dependent on his V initial y. So I'm going to use V initial y here. to figure out that if an object is traveling, so I'm going to write on here, he is going straight up into the air with some v initial y. He reaches his highest point where y is equal to 0. And then over here, his final vy should be the same as his initial vy, but in the opposite direction. The fact that he's moving horizontally has nothing to do with that fact. He's going straight up, straight down, dependent on gravity. So we just want to find out how long that would take. So if I start out with my equation that v final y, and I want to use subscripts from now on because I want to make sure I never get a y and an x mixed up in my equations. If I'm going to do an equation for the y direction, I only better have y variables in that equation. Vy equals v initial y plus gt, and g is negative here, so just realize that that's actually going to be minus that term when I fill it out or solve for it. So I'm finding t here, so t is going to be vy minus v initial y over g. Okay, I just did a little algebra there. And t has to be positive, so when I take vy minus v initial y, we'll see that we're going to get a negative value there, so it's negative over negative will give me a positive time, which it always has to be. Now there's a couple ways you could approach this conceptually, and I kind of, the fact that it's a nice symmetrical even plane, if vy going up is positive 10.7 meters per second, then vy over here at the end of the ramp has to be negative 10.7 meters per second. Another approach to this that some people like to take is that instead of looking at the whole trip up and down, we know that vy is also always 0 at the highest point. So if I do vy here is 0 at the highest point, then the time I'm actually going to get will be half the time, right? Because that'll tell me how long it takes to get to my highest point. But I'm going to go ahead and solve it all out. It's symmetrical. I don't have to worry about having a different time up and a different time down and all that. So now I can just work this out. Vy is negative 10.7 meters per second minus v initial is positive over g. It's Webassign, so I'll go ahead and use the 9.8. So in other words, his total change in velocity here is from positive 10.7 to negative 10.7 at a rate of 9.8 meters per second per second. So that's going to give me a overall, calculating here, time of about 2.18 seconds because his change is his change in velocity is 21.4 meters per second at a rate of 9.8 meters per second squared. So that's going to give me a total time of 2.14 seconds, right? So let's recap. We broke our vectors down into x and y components over here, always our first step. I kind of tabled over here what we're going to be doing ultimately in the end with our x components. I had to really come back to my y though because I can't figure out how long it's in the air unless I use my vy. So my initial vy was 10.7 that I got from resolving the vector first. Since it's a symmetrical, it lands at the same point. It's coming down with the same speed that it started up with, giving me a total change, right? That's my delta v of total change of negative 21.4 meters per second at a rate of 9.8 meters per second means it takes 2.14 seconds. So now I know that this guy is going to be in the air for 2.14 seconds, which simply means that how far is the motorcycle going to go? Well, he's traveling at 33.3 meters per second. Remember, that's Vx. That's not my overall speed. I resolved it into Vx. And he is moving with a constant speed of that for the entire 2.14 seconds. So that's going to give me a 33.3 times 2.14 is 71.3 total meters, right? So my dx is what I just found, 71.3 meters. And now we can just kind of wrap this thing up. The question is asking us about how many buses. So if each bus in my problem is 2.74 meters wide, and he travels 71.3 meters, and each bus is 2.74 meters per bus, right? Then I'm going to get buses. So 71.3 divided by 2.74 gives me 20. Now, with my numbers, I get 26.02 buses. So if he can jump over 26.02 buses, well, there's no such thing as a .02 bus. So I'm going to, no matter what I get here, I'm always going to have to round it backwards to my last whole number of buses. That's pretty impressive, 26 buses. So he should be able to jump over 26 school buses with that trajectory. Now yours might come out to be a little bit different, but I really want you to think about what you're doing as you solve this problem. You're solving, again, this is just a one-dimensional problem. This is a simple one-dimensional problem. Together, though, they make a nice little projectile problem.